a name created from this, and it uses any of these keywords that you are seeing on your screen. For example, I cannot create a variable called throws, right? Maybe because I want to keep the number of throws someone has made, and I call it throws. Why? Because throws right there is a reserved word, or it is a keyword. I cannot create a variable and call it private, because maybe I want to store how many private companies I've worked with. Um, so these are off the limits because they mean something to the language. That's where we ended. Let's continue with our introduction to JavaScript. I'm sorry, JavaScript. Our introduction to Java. And one of the things that we're going to be dealing with mostly is the Java development environment. Well, if there are many, there are Java development environments. What actually they contain, or what you'll find in most of these environments, is something we call the Java Development Kit, or the JDK. Now, the JDK can be downloaded and installed. In fact, on your computers, those of you that have them, you will install the JDK. But also in that lab, because most of our sessions are happening there, in that lab, we will get this set up. So we'll install a JDK on that machine, on those machines that you'll be using, and you'll be able to start running programs. Now, what the JDK really is a toolkit that contains most of the things that you need to start writing Java applications or Java programs. What it contains mostly, I think I'll need to edit this so that it adds something else. It contains the Java runtime environment, which is called JRE, Java runtime environment. The Java development kit is a JDK, and the Java runtime environment is found inside the JDK. Now, it is inside the JDK that the JVM, or the Java Virtual Machine, is found. So the hierarchy would look like this. You have JDK. By now, you know what a hierarchy is. You have JDK, you have JRE, and then you have the JVM. Now, inside the JVM is where you find lots of things that you will get to learn along the way. So the Java runtime environment is meant to run pre-compiled Java programs or pre-compiled code. Okay, so in most of the cases, when you're defining the JDK or the Java development kit, you call it a toolkit. It contains everything. It is not the JDK that runs. There is a component in the JDK that runs our code. Now, that component that runs the code is what we are calling the Java runtime environment. But then the code before it is run has to be compiled. I hope you remember. Excuse me. I hope you remember that this was pointed out in the previous class, that just like we write C or C++ code, it is compiled into what we called machine code or object code. Now, the equivalent of object code in Java is what we call the byte code. So your source code, whatever you have written in text editors, will be converted to bytecode. Now, bytecode is what is run. So the component inside the JDK that is in charge of converting the Java code that you've written, the source code that you've written into bytecode, is the JVM. So JDK toolkit that contains everything that you need to write, run, compile, and debug your Java programs. The JRE, on the other hand, is exactly what you use to run the Java runtime environment. So it is used to run pre-compiled code. Yet the JVM, the Java Virtual Machine, is what converts our code. Okay, converts our code into the corresponding bytecode and even executes it. So when the code, wait, in fact, the JVM also has an abstract thing. Itself is not the one that does the actual conversion, right? The actual converting of the code. We also install a compiler and you'll see it, but this code is run on the JVM. I don't know if you guys have heard of virtual machines before as a concept. They usually teach it in networking and operating systems. But if you haven't heard about it, really it is as straight as you hear it. Virtual machine. So a virtual machine is like a mimic of your actual physical machine. More like how I have one operating system installed on this machine, I can have 10 of them installed on the same the same machine. How do I do that? I create a virtual environment where I can install one operating system. Through the same virtual environment, I can install multiple other systems. So that virtual environment is what we call a virtual machine. It's like owning multiple computers. So you like simulate having multiple computers. So the Java virtual machine is something that we actually use to run the bytecode. So the bytecode that the compiler gives us, we shall see what compiler this is. Those of us that were studying C, we were using GCC to compile. Those of you that were using C++, I don't know if they explicitly told you, but the compiler that we mostly use is G++. And it turns out that Java itself has a compiler called Java C. So most of these components are also found within these things. That's why earlier I stated that the JVM is used to convert into bytecode, but the actual component of the JVM in there that does the creation of the conversion of source code to bytecode is the Java compiler. The C here is for compiling. And so the JVM now will be the one running. Its actual task is to run the bytecode. Java compiler converts the source code into bytecode. The Java virtual machine runs what has been converted. Let's clear this away and move on. So you guys have heard of integrated development environments or IDEs. In fact, in the languages that you've learned so far, you are using an IDE. This IDE is um, the environment where you run your code, or not run, type and run everything, because this IDE can also be called a text editor or just an editor. Now, things like VS Code, I will be using VS Code, but I want to think that you are also using VS Code in the other classes. But some of the other examples that people use, there's one called NetBeans, there's another one called Eclipse. You can use JCreator, you can use JBuilder, but you can also add VS Code to the mix. Okay, you'll find people use another one called Atom. You'll find there's one by what's that company? What's that company? NetBrains, JetBrains. It's called. Um, I think I even have it on the desktop. Let me just be sure before I confuse myself and you as well. No, not you, not you, not you. There is another version. Mm, IntelliJ. There's another one. Unless I can't really seem to see it. And I'm sure I had it at some point. Okay, maybe it's not even PyCharm. Let me just confirm here. Yeah, it should be this, the IntelliJ IDEA. It has another name that I feel is running out of my head. Um, let's see. Just give me a second. I need to get this right. I don't want to keep scratching my head and then out of the blue I remember it when we are done. Come on, you cannot run out like that. Are you still loading? Mm-hmm. 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 Mm, no, it's closed. Yeah, actually, it's called IntelliJ. IntelliJ, but these guys have IntelliJ IDEA, but they have different, different IDEs that they have developed. The company that developed this is called JetBrains. So JetBrains is one of those other companies that maybe you hear of. Like we had Oracle, and Oracle being the one that Oracle being the one that developed Java. So these guys are also one of those people that now develop applications that you can use to write Java programs, but they also have a language called Kotlin. This was what you've just seen was a simple program. I was trying to learn the language. So I guess that's what you saw in there, but never mind. So IntelliJ is another IDE that you can use, but for it is IntelliJ idea in capital letters. Each of those characters means something. We don't have to worry about them. So there are there are many IDEs that you can use. Most of us just pick one and focus on that, or use like two. You don't learn all of them, except for testing purposes. Like you've seen, I happen to have NetBeans. I also have Eclipse on my machine, but I also have IntelliJ IDEA. I also have the others, like three, four, five of them. Because usually, as you're teaching, you find one that makes your students' life easier, or also depending on what are you trying to work on, because each of them might be good for something that the other one does not give. So we shall see when we get there. For now, we shall be using VS Code until we get to a point where maybe we are creating these applications that have graphical user interfaces. Then we'll see how to use either NetBeans or Eclipse. We might use NetBeans, by the way. So these IDEs, or integrated development environments, they provide sophisticated code editors or text editors. The editors, that environment where you type your code, is what we are referring to as an editor. So all of it is found inside the IDE, and the IDE combines multiple things. That's why we call it integrated. And of course, it also has debugging tools. Let's say there is an error on line 15. The tool that shows you that error is a debugging tool. And I'm sure by now you know what debugging is, that process of finding errors in your programs or finding bugs in your programs. They also contain graphical development tools. The graphical development tools are like, instead of writing code, let's say I have a page and I'm trying to create. Oh, by the way, I also happen to have some flu, so when you hear me breathing funnily, please don't mind me. You can laugh, you're allowed to, but make sure I don't hear you. So we have, let's say I want to have a button here, that be like a screen, a display sort of screen. So I'm creating maybe a calculator program, and I have a button here, have another one there, and another one here. Then, um, and stuff like that. Okay, maybe down here we put the equals. Okay, so this is equals. Maybe this is just one, this is two, this is three, and then four. And then here it is, there's a plus, there's a minus. Okay, and the results will be shown on the screen here. So most of these tools contain a way to just drag and drop these buttons on an interface instead of writing from scratch each. Now you will see that in VS Code, we'll be writing each element from scratch. Even if you're trying to come up with a graphical user interface, you need to write the code to come up with this button. Write another one to come up with this, another one with this, another one with this, and even the way you want it to be formatted. You want it large, long? Do you want it to be, blurry, or you want it to be more standing out, like you bolden the text and stuff like that? You would have to write the code for each was. Yet in a couple of IDEs, like NetBeans or Eclipse, excuse me, you will have to just pick, there is an option here for button. You drag it, you drop it on the interface, you put it in the right direction, right position where you want it. Then you even go and add comments, so not comments per se, add like settings that maybe make it work the way you want instead of writing the code. So those are the graphical development environments, or graphical development tools. We will see how to use them. Now, at the bottom here, I added a link that contains more definitions for these things. What the JVM is, what the JRE is, what the JDK is, and how are they different? So, because people might wonder, what? Yes, you've mentioned JVM, JDK, JRE. Can we use one of them and choose not to use the other? Or when you install one, it installs all of them? Do I need to install each of them separately and stuff like that? You will find those definitions and explanations on that page. Let's dive into the basic syntax of a Java program, or what sort of structure you're going to write for your Java programs. If you remember the definition for Java, we called it a class-based high-level language. We even removed the OOP thing. It's a class-based high-level language, meaning almost everything that you need to do is written under a class. And so most of your programs will always be put in a class. So you need a class name. But then here you see us using some of the keywords that we saw earlier in the other table, public and then class. So public is simply meant to tell the compiler or the computer or whichever other component wants to access this class, that it is available for public consumption or public usage. And what you are creating is a class, not other things. You will see things like packages, you see things like interfaces and stuff like that. So you have to explicitly tell us what are you creating and what access levels are you giving it. So we said earlier there are three main access specifiers or modifiers. There's private, public, and protected. For now, we only want to create, most of the classes you create will be public. And the reason for that is because you want them to be run. If your class contains a method, that thing that we call an entry point in other programs like C++, the main method. If your class contains the main method, it will definitely be public by default. And so the keyword class, and then what name are you giving it? Is your class called hello? Is your class called student? Is your class called person? Is your class called cars? So this is where you're going to put the name. Then you open the curly braces. And inside there, you have your main function. Now, the syntax for the main function is something that for now we don't have to explain. I understand every word that is in there, but the most important thing is that it is the main function. If you remove this and remove that, you see that this almost also, if when you remove this, you see that this looks like the main function from the other languages. The difference is that we always called this, or we always put int main. But by the time you see void, you know it is not returning anything. But if it was to return something, we would put int there. So let's bring back the other keywords. You know now that public simply means we need this to be accessed outside this file, because each program you create, I mean, each class that you create under normal circumstances is meant to be a file, a separate file. There are times where you can put multiple classes in the same file, but that's not advised to be done. We prefer to separate, and I think we talked about it, separation of concerns. You separate your concerns. This class is concerned with students, so I'll put it in file one. This other class is concerned with parents. I'll put everything in the parents class, and there's a file for that. So normally, when you want your main function to be run, should be made public. And then static, we talked about static methods and non-static methods, all class methods and instance methods. We talked about them. So this is a method that is static. What that means is that it is going to contain common information about this class. There are other reasons. Let's not worry about them, but we know that this means it doesn't return anything. It's the main function. It is taking a parameter. Okay, there's one parameter or one argument, if you want to call it that. It's taking one parameter, and this parameter, it contains some notation that you've seen before. This is what we use when we are referring to arrays. But it also has something here called string that starts with a capital S. Now, this is another takeaway. Anything in Java that starts with capital S, it means it is a class. A class most class names start with capital S, meaning even yours, you will name them starting with capital A letters. So let's say, wait, I said most classes start with capital S. Most classes start with capital letters in their namings. So if I was creating a class called student, so public class student, student here would be with capital S. Public class person, person would be with capital P. So when I see this usage, in my head, I know that there exists a class called string. Okay, so there's a string, a class called string, and we are creating a string array because that's what these brackets means. And then the variable name is args. But really, if you, for now, you don't have to stress too much. Yeah, just read this as string arguments. Okay, so the main function takes string arguments, an array of arguments of which their data type is string. But that's not a problem. Then inside the main method, we put multiple statements. Are you trying to just print hello world on the screen? Are you trying to pick inputs from the user? All of those are specified within here. You will also see maybe you are trying to instantiate a class. You want to create objects. Maybe you want to create variables that are not just objects and stuff like that. So this is like the general structure of your classes. Now, the takeaway here is the class name that you give your file, or the class that you give, this class name here is supposed to be the name of your file. Meaning, if this class is called student, I will save this in a file called student.java. Notice the capital S is also supposed to cut across here. If this class is called person, I'll save it in a file called person.java. Person with small letters would be a different thing compared to person with capital letters. I think this we've also talked about that most of these programming languages are case sensitive. They are case sensitive, meaning that person with capital P and person with small p are two different persons at that. So the name that you give your class should match the name that you give your file should match the name that you give the class. And go on. So this is an explanation to what I've been saying while they were appearing. So class is used for every Java application. Whatever you decide to write, all your Java applications will always contain a class unless otherwise. We'll see that part of unless otherwise when we get there, but almost all Java applications will contain a class. But maybe to narrow it down, all Java applications that have a main method in them are created as classes. So if what you're creating doesn't need a main method, then you might not have to create a class. You might have to create something else. The main method is considered your entry point, just like we saw the main method the other side. So even here, it's the usage is still the same, the entry point of all your Java programs. Meaning, if you have 4 classes, there should, if the 4 classes contain student, parent, lecturer, maybe getman, there should be a 5th class that will be used to call all these 4 classes. One of those 4 classes should contain a main method, because when you start running the program, the JVM will be looking through your bytecode for a method called main. If I find a class called student and doesn't contain a main method, I ignore that class because I don't know how to use it. If I go and find another one called student and called parent and it doesn't contain a main method, I'll still ignore it. That's what the JVM really does. Until it meets a file or a class that contains a main method, then it starts execution from there. If there are any errors, they'll be traced down the line up to the file where they are. We shall see that. But if you write your Java application and you want it to display some sort of information, you always need a main method because it is the entry point for all your Java programs. And this is the syntax for the main method. It does not change. We can add other things, but we cannot remove anything. Let's put it that way. Yes, it can change, but when we are adding things, but not removing. So it's always going to be public, so it's going to be static, so it's going to be void, and so it's going to be main, and then contain these string arguments. In due time, we will understand what these string arguments are. They might be the only confusion here for now. And of course, statements can include maybe the printing statements, the statements that pick information from the user, the statements that you use to perform computations and calculations and stuff like that. Let us demonstrate this in a program called hello, right? .java. While we're here, I'm going to ask a question. What is going to be the name of the class that I create inside a file called hello.java? What is going to be the name of the class that I create inside a file called hello.java? Think of this as a way of checking on you and how you are. The first person. Today I will not start with the first person. They might cry. Let me go with, I'll just randomly pick. How about Kagere Anthony? Yes, Anthony. Mm. Do you remember the question? Pardon?
It will be called hello.
It
The
will be
class will be
called
called
Hello.
hello.
Okay, so the reason I asked that, it might sound obvious, right? But I mentioned there's a relationship between the file name and the class that you are going to create. Now, these are kind of questions that you can even find, by the way, in an exam or a test, where I will take a screenshot like this, okay, and say, what is the file name for the following class? And these are what we call free marks, because you should know that if a class is called hello, then it is saved inside a file called hello.java. In fact, the development environments that we use also are strict that they give us errors. If you create a file and call it hellos, okay, hellos with s dot java, and then you create a class called hello, you will run into an error because it is trying to find the file is called hellos, that the class inside here should be called hellos too. I hope that that makes sense. We move on to our main method, and it looks pretty much like that because that's what it is really. And then inside there, we have a statement. So this is how we output information. Okay, this is how we output information on the screen. And I would have asked, but for now I'll explain. I'll ask some other time. You remember when I said everything that starts with a capital letter is a class? This is a class. That is also a class. So there's a class called string. And but this also reminds you, it's a reminder that we were told, I mean, we're talking about the advantages of OOP, and we said code reusage, code reusability. If someone has already developed some functionality and you have access to that functionality, just reuse it. Do not reinvent the wheel. So this string class contains some functionality. That's why we're using it here. But actually, to even output information, for you to see this information, we use the system class. So the system class is a class that contains everything that you need to output information. Most of it will even contain how to write information to a file, not just to the screen, but to a file, because writing information to a file is also a sort of output. So you will find that in system.out. So system.out is the corresponding class that is in charge of writing information to what we call the output stream. The output stream is actually your screen. It's just that in certain books, you will find that being called the output stream. A stream, by definition, is a sequence of characters. Okay, a stream is a sequence of characters showing the flow of data from. Well, I'll write this because it's a slightly long definition. But here, here, we define a stream because you find it a lot. A stream is a sequence of data. We can even say flowing between input stroke output devices and a program. This is the definition that you find out there for a stream. So whenever you see output stream, input stream, you know what that means. That we are showing the data that is coming from, that is going to the output, the input, that's being input. We are showing data that is being output. So input stream, output stream correspondingly contain data also. So system.out. System.out is the corresponding output stream, the one that contains all the information which is being displayed on the screen. We shall see another one, system.in, which is supposed to actually be obvious if you can relate in and out. So system.in is the corresponding output stream that sorry, the corresponding input stream that we use to contain information or data that comes from the keyboard. So to now display a message, since we are dealing with a class, that class has a method called print. And that method takes in one parameter, which is a string. That's why we put it in double quotes. So whatever you put in double quotes is going to be used to, it's going to be directly displayed on the screen. That's if you put it inside your system.out.print. And of course, that is one way to display information. There are other ways. Here is a that makes sense. Someone says it was clear, and I hope it is clear for everyone. So we move on to those. Okay, the first one that we've seen on the previous slide. But the expression might be. A can be considered an expression because it will also be evaluated. We shall get whatever value is in A and display it on the screen. Now, this one here, this is for line really. And when you just use it like this, a blank line. Whereas the last one takes in some sort of expression. So system.out.println, okay, system.out.println, and you give it an expression. When it is done printing information, it will automatically go to the next line. I wonder if this reminds you something about the use of, let's say, cout, and print f. By default, printf and cout work like this. Okay, they work like the system.out.print. So if you're trying to see how the two languages are related, cout is the equivalent of system.out.print. Sorry, for us who are learning C++. Those of us that learn printf is the equivalent of system.out.print. But we know how to actually add a that thing that we say the blank line using the new line feed. Even here in C++, you guys would write something like this, which is still similar to what we also write in C. It would look like, maybe I want you to print hello, and when you're done, go to the next line. That is version 1 of the C++ world. But the same C++ people can actually write cout, and they put in brackets hello, maybe full stop, and then they come here and say end line or end L. These two will do the same thing with the exception that end L adds some extra work, but we don't have to go in there. Whereas the people from C would do print F, say hello, \n. These statements are going to do the same. Print the message on the screen and go to the next line. Print the message on the screen and go to the next line. So that is the same, that's the equivalent of this last one that you are seeing, right? Meaning backslash L alone is the equivalent of that, because that's what prints an empty line. So if I was to come and just say print F and put put in double quotes and do that, that's the same as saying go to print print a blank line. So backslash n is the equivalent of what is in the middle there. So now, probably this makes sense. That's how you output information. When you do this, it's going to be displayed on the same line. You do that, it will print an empty line or a blank line. You do that, it prints the information and then adds a blank line after. But here, we can now start using that in our Java classes or in our Java programs extensively. So let's come up with a class together. Most of the times our classes, and I think by now we know, because it has been said, all programs contain comments. What do we use comments for? We use comments to give some sort of descriptive information. The descriptive information could be to us who are writing the program or to someone else who will come to read the program. Maybe your manager, maybe your line supervisor, maybe, whoever it is, your senior, and you're working on a project together and you added some sort of logic and you want when they come, you don't want them to ask you because maybe you might not be around. Just you put a comment before the function that says this function is meant to ABCD. The corresponding logic I used was to da, 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 da. So that even if you come back 2 years later, after working on this project, you come back 2 years later, you can read these comments and understand what they are about. The other thing that you will find in Java code are variable definitions. We know what variable definitions are from other languages. They still hold even here. A variable definition is going to be what we tell the compiler or the way we tell the compiler to reserve for us some space in memory. I want you to reserve a space in memory and give it the name A, and that space will save an integer or store an integer. I want you to create a space called X, and I will save a long or double or short in that. Okay, and this is the demonstration. And then, of course, this is the Boolean data type, the one that stores true and false. Its usage is slightly different. Okay, before maybe it might be the first time some of us are seeing it. So Boolean stores one of two values. It's either true or false. Thus, if you want to store we usually call them flags. Whenever you're storing Boolean, we call them flags. So is found flag is how you read this. So you want to store if something has been found by saying true or false. Maybe you're looking for a certain value in a large data set, and you need to keep track of I found it, I have not found it. All you need to somehow you're searching for a name from a database, and you need something to tell you whether the name exists or it doesn't. The database might return some sort of value, but maybe you're not interested in that value. You just want to tell the next person or the compiler the person who is asking for that value, that the value you're looking for is actually there. I have found it. We usually use the Boolean data type. In other languages, I think in C and also C++, it's called bool, like that. With it stores 1 and 0. 1 for true, 0 for false. But then we also say 0 is for false, okay? Whereas any other non-zero value means true. So in this case, -2 would mean true. 1 would also mean true. -1, -1,000 would be true, but 0 alone means false. So here in Java, it is either true or false, not 1 or 0. We know what double is. It stores large floating point values. And now here is a way that we store strings that is different from what you guys did in C, where you would create like a character array and then you assign it values. Here, Java it has a class called string that you can use. But now I want you to see there's a difference in the usage here. Let me erase. Do you notice that int, boolean, double are in small letters, yet string is in capital letters? So this simply tells us one thing. This is a class. These are not created from classes. They are primitive data types. They are inbuilt data types, but we shall learn data types are also somewhere in there. I don't know if it's in this lecture or the next one. So this is how you would create. Let's say you want to save your name. You would just write string. Let's say here, I can create a variable, say name, string name is equal to, then I put in quotes, George. Okay, George. And then I have to terminate because this is supposed to be an executable statement. So now you can imagine having different or creating name of variables that are going to show up different people's names. This is what you would do. So a string is a class, and it is not us that wrote it. It was written by some people, and thus we can just reuse what they wrote and save ourselves the hassle. We'll talk more about that along the way. We know the naming convention. The naming convention is the rules that we talked about at some point for creating identifiers. And when I said talked about, I also know that the people that did principles of programming should have talked about this. There are different rules. And these rules, one of them is the fact that the overarching one really is that the name should contain special characters, certain special characters, digits, and numbers, sorry, and letters. But the name cannot start with a digit. Thus, I cannot say one number to mean first number, just like you would have said first number, second number, and you say one number. This would be invalid because a digit is appearing before a letter. And then the other one is not exactly a rule per se, but it is something we call camel casing. Camel casing or camel casing is a way of naming variables that allows us to sort of capitalize the first letter of every word in the name except the first one. What this means is that if you look at this is a number, right? A would be considered the first one. If I were to write it, I would write it as a number normally like this. Thus, with camel casing, the rule is this second one, make it capital letters, but this first one will be small letters, so a number, because we know one of the other rules is you cannot have a variable that has spaces, a variable name that has spaces. A space number would be an invalid variable name, so I cannot create this. Yet, actually, still the same rule comes and says if you want to use, instead of using a space, substitute it with an underscore. This would be a valid name, right? So with, but then underscores also create a sort of funny looking names. Thus, some people came up with a different way, a better way at that. Instead of someone writing a number like this, okay, or a number like that, they say, okay, so let's get for each word that comes after the first one, let's capitalize it. That's why you see is found, the F starts with capital. Another number, the N starts with capital. But because S is the only word there, we don't capitalize it because that would change the meaning behind the variable name. The variable name, most of the times, should be in small letters. But we also allow the Tago casing or the camel casing or mixed casing like that. Meaning, if I wanted to create a variable that has a name, say I'm creating a variable, but that variable is out of my name that has, and I have three of them, it would look like int, let's make this bigger. So int George, and now the William will start with capital, Sazi, like that, right? And then like that, okay? So this is a valid camel casing name simply because of these things. The way we have that capitalized, that, and that. So when you see it, now you know what camel casing is. We'll move on. That's why we're saying note there. That's why there's a note here that says you need to pay attention to the naming convention. Well, besides comments and variable definitions, our code will also, the Java code will also contain method definitions. So we are learning how to build a Java class, but we've said everything that you write in Java for now is a class. Thus, we need to know what do we include in our classes. We'll put comments, we'll put variable definitions, we'll also put method definitions. So now, what are comments? Comments have, there's no definition for comments here, but we have multiple kinds of comments. We know types of comments, sorry, single line, multi-line, Java adds another one. These ones are common from the languages you know already. Java adds another one. It's also a multiline, but it is used mainly for documentation. We know what documentation should be. That maybe I want to generate, a user manual. So I want to generate a user manual for my users. If you want it to be automatically generated, you would write it like this. Okay. So the notation here is different. You see how you have multiline with one asterisk or star. Here now you have two of them. The way we'll see the way it is rendered is also different. We shall test it in especially NetBeans or Eclipse. You might not see a difference, and I'm saying you might not, but we may be. Some versions of VS Code might show the difference, but we will see when we test it out. So this is meant for documentation, maybe some sort of official documentation that will be generated and maybe converted into a PDF. These comments, these ones here, you can't do anything with them. They remain within the program. But there's a functionality that Java gives you that can allow you to compile all of the multiline comments that match this description into a PDF. Maybe you want your technical developers to be able to look through the code and know where to find what. So the official documentation that the tools would use is this instead of this. So this is for us human beings. These two are for human beings. Whereas this last one is like for a sort of tool, if you want to call it that. Moving on. The tool is JavaDoc, but don't worry. So comments do not appear. We don't even need to waste time. Identifiers, we talked about identifiers. These are just some of the comments that show you what identifiers are. In fact, all I will do is I've already explained this, how Java is case sensitive. I'll just give you a simple test. What I want you to do for me is to identify which ones are valid and which ones are not. Okay. So I pick you. You tell me which one is a valid. Just pick one so that other people can also respond. Which one is valid, okay, and which one is not. So let's see. Who do we start with? I think Anthony. Was it Anthony that gave us the answer? Yeah, it was. So I will now look for a lady. Fair enough. So which lady is lucky or unlucky, maybe? Stella, you're the first lady that I've seen from Anthony going down. Nakasi Stella, the next person below you is Nachira Letitia. So Stella, which one is a variable? Which one is valid? Just pick valid. I'll keep checking them off the list. You have
K.
A, B, C. K is valid.
Yes, I think so.
Okay. Ah, okay. I don't think I want to. Do you want to give a different answer? Because I want to refuse that one. What reason do you have? Yeah, okay, let's say, what reason do you have for thinking this is valid? K is what you say. Not sure? Need more time to think? Okay,
Yeah.
let's see. I see Mpanga John Paul. Would you mind sharing with us which one is a valid identifier? Mpanga John Paul?
The main C.
C. Could you defend that, please?
It is a recognized.
It's a recognized variable name. Okay. Okay. Does anyone have a comment about both about Stella's answer and Panga's answer?
I think the identifier is D. D F and I.
Hey, calm down, calm down. I'm looking for 1-1 One want to answer, my guy. You don't want people to contribute. Yeah. My question was, any comment about what Stella gave and what Mr. Mpanga, in case they call you Mr. And you're like, that guy doesn't even call me Mr. and I'm taller than him. Mr. Mpanga, what you gave. Any comments? I'm not looking for the right answers. For now, I want comments about what Mpanga and Stella have given.
Yes, I think that Stella's answer of K is not correct because it starts with a capital letter. And then I don't know, is main I believe it may be one of those words that you can't use. I forgot what they call them in Java.
I don't know. I am the one asking a question, but hey, you want to ask me instead? Well, so one, Stella, this is the reserved word. String is a class, right? And we've used it already for something. You've seen string S, okay? So this is a class that someone developed. Thus, we cannot use it as a valid variable name, meaning this is wrong. Now, the reason I asked you about main is from some other languages. Now, like in C or even C++, you might find they are reserved. But actually, is it even? By the way, even in C. So the reason usually people can confuse it is when it has this, you can't use it as an identifier. Okay, when it has those brackets, because that makes it a function. When it doesn't have them, it can be used as a valid identifier. Now, the reason I asked the person, I thought they would tell me or they would explain to me that bit, that main is just a word without the brackets. The brackets are what convert it into a function. Without those brackets, main is just a word. So main is valid. Okay. Let's see. Let me just do this. Okay. Main is valid. Let's see, who do I pick here to give us something? Aine. Aine, which other one do you think is a valid identifier?
I.
Yes, I is also valid. Why? It starts with a letter, it has an underscore, that is a number. So the number is not what starts, so I is valid. Al-Mahad bin Umar. That's the name I am seeing right after. Umal, are you here with us? So you can tell us which one is a valid identifier.
K.
Okay. Umal, were you listening?
Yes, I've been following.
And you're saying K is a valid identifier?
Yes.
Could you please pick another one? Okay, besides K, which other one is valid?
A.
Well, A is actually valid, but K is not. I even explained why, but thank you. Among the ones that are remaining, which one is valid? Let's see. Atala Pasca. Pasca, what do you think?
Yes, sir.
Yes, madam. Did you hear the question?
Yes, but
We're looking for
I'm
valid
not sure.
identifiers. Okay, no problem at
I'm
all.
not sure.
Bale. Fine, don't worry. Bale, Trevor. Do you have any suggestions?
Yes,
Trevor?
sir. I'm not sure about it.
Okay. Let's see. Who do we have? Doreen K. Doreen K. Doreen. Which of the remaining ones is a valid identifier? So far we have picked A, C, and I. At least K has been crossed out. But actually, feel free to also tell me which one is invalid if you want to use that. So we just cross it out. So Doreen, are you there? Hmm? Is Doreen there with us? Here with us, sorry.
Yes, sir.
Oh, you need more time to think? Or you're not sure?
So we are having tufa. That is E and F.
Wait. Are you speaking on behalf of Doreen or
Sir, there are no more.
there are no more?
Yes.
Okay. Thank you, Doreen. Uh, Now wait, Namara, do they call you modern as in your real name? Please unmute and start with that. Do they actually call you modern? Because I saw modern Namara,
Yes,
and I wonder, is modern your name?
yes, yes,
It
all right.
is. Okay.
Yes.
Please
I would like you
proceed.
to clarify more about part K, the string.
Part
Why it
K,
is not, why is it invalid?
why it is invalid?
Yes.
Okay. Well, the reason is because it is already used. Okay, it's already used as a data type. An identifier is something that we use to give a name, right? A name to a class. Now, wait, did I say class? Not a class per se. I meant a name to a variable, a name to a class itself, a name to a function, a method, and stuff like that. Now, the problem that is going to come here is, look at this. Let me just write on this side. So when we come here and write string s, the interpretation behind this, just like int x or double y, the interpretation is double is a reserved word, right? Now, string is not exactly a reserved word because it was not there among the list of things that we have. But Java, when you give it, let's say you create, it's like, can you create a variable string like and do that? So this is why you need to ask yourself, like, if you go to the internet, by the way, and you type a question like, is string in capital S, is string a valid identifier in Java? Stupidly, it will tell you yes. Why? Because I mean, most AI tools will tell you that, but in reality, no, it is not. Simply because, can you do this? Can you logically say string, string? Because now, which one is the class? Which one is the object? Okay, maybe it's bringing objects right now might be a problem, but just like you do int x double y, you cannot use double. You cannot say int double, right? As in int double, because the double would be the identifier. Now, even here, when you say string, the first string is the name of the class. The second string is string. Though string itself to S does not contain a predefined meaning that Java reserves, it means something. It is a class that someone wrote that contains string manipulation functions or functions that we can use to deal with strings. Strings, your name is a string, anything that combines multiple characters and puts in double quotes is a string. Thus, we should not, we can, but we should not use string as a variable name. The reason for that is the sort of ambiguity, like it will be ambiguous. The compiler will keep trying to find what exactly are you trying to mean here? It might not bring an error, but some actually will. There are some that will give you the error, some others will not. So that is why I said K is invalid, because string is not part of the reserved keywords, but it means something to most of these compilers because it's a class that someone wrote, though it wasn't among the keywords that we have the other side. I don't know if that answers your question, Modern. Are you convinced?
Yes. All right, I'm convinced.
Yeah. But you could have said you're not convinced, so I keep speaking English. All right. But Modern, from the ones that are remaining, which one do you think is valid or invalid? Or do you say all of them are invalid? Hey, Modern, you just muted. I thought I would get something from you. Just like I've answered your question, please answer mine. Don't run, don't just run away.
All right. I think from the one that have remained, I may say D is invalid because it is made of special stars.
Oh, okay. Thank you. That is a nice perspective, really. But what do people think? Hmm? Yes, Emmanuel, you have your hand up.
Yes, it is invalid because it contains special characters, and we choose special characters.
Oh, I will come back to that. Samuel, you are unmuted, sorry. Do you want to say something? Okay. I guess, yes, Priscilla.
I think D is valid because the dollar sign is it's an allowed character. You can start with it when you're in an identifier can have the dollar sign. So I think it's valid.
Okay. Well, when I said I'll come back to that, that's what I wanted to say. Yes, the dollar sign is actually allowed. It does not hold any special meaning in the language Java. Okay. But there are some that are not allowed. In fact, thank you for the contributions. I'll just end it there and point out what I want to show you. This is definitely not valid because of the space, right? You see the space there, so that's invalid. This is also not valid because it starts with a name. I mean, well, that's one. So one is a digit. I cannot start with it. That is also invalid because of that. Interestingly, this is also invalid. And the reason it is invalid here, the reason it is invalid is because the backslash, this guy, has a special meaning in Java, and in fact, in most languages. Just like you saw forward slash and backslash, you've seen, well, this is forward slash, not backslash. The forward slash has a special meaning, just like the backslash. It's considered a special character. Okay, thus it cannot be used in a variable name, not even at the beginning or not. It should not appear anywhere. It will be the same if you put backslash. Remember what you've been writing, backslash n. And the moment you put the backslash there, whatever is coming after is considered not as n, but as a combination of backslash and n. Backslash a, backslash b might mean something else compared to just b. Well, you might find that backslash a means nothing, by the way, and that's even when you use it, the language doesn't understand it. But also the forward slash is another of those special characters that you should not use in your names. Where have you seen this being used? You've seen it in spaces like C, backslash, then maybe users, forward slash, users, then maybe PC, maybe then desktop. The symbol that they use is this. So it is a special symbol that holds a certain sort of value, so to say.
Yes, sir.
Yes, please. Is that a question or?
So I was requesting for a permission from you. We have some friendly match at the pitch, sense, and they want us by 3. I wanted to leave now. I don't know. Can allow me?
Please. I am not allowing you, but feel free to go. Actually, there is a recording. Someone is recording the sessions. We shall keep going. You'll ask them to share with you the recording. That's Timothy. He will share with you the recording. Okay.
Okay. Thank you, sir.
You are welcome, Umar. I don't know if they say it as Umal, but Umal is, I think, more intuitive. Well, now the last one is this. This Dora sign means nothing to the language, thus it is valid. So they have signs that symbols that you will use that are considered to be special characters, special in the sense that they mean something and they will not, they will create, they make the name invalid. Yet there are others that will be used and they hold no sort of meaning, and thus they will, you'll be allowed to use them. Okay, so there is a list of all of these special characters and special symbols that you should not use, but at least we know all letters, all digits can be part of the name. Now you just need to be wary what sort of character are you adding in there. Usually why we say this, because this is not easy to confuse, but you can have a variable name that some variable names that look like, let's see, student, but I think Java would not allow this percentage S. Yeah, it will not allow this because this means something, but there are some languages like PHP that will allow you to have this, and the funny languages anyway. So we move on to the variable definitions. We know what a variable definition is by now. The only difference is that here we are going to also encounter some variable definitions that use data types that are not inbuilt. Like int is inbuilt. You even know it from other languages. But string uses something we call a custom defined or a reference data type. The structure, though, is still the same. You tell us the data type, the name of the variable, and you can stop there if you just want that. But you can even assign values. Someone is unmuted. I don't know who that was, but please, unless you want to say something, please don't unmute. So, I mean, you can assign values here, okay, and give it maybe the corresponding value. So the structure, the syntax is still the same. The data type has to be there. The name, the identifier, or the name of the variable has to be there. The assignment operator, which comes, right, which associates this with a given value, and then you terminate. So here we are creating a string called S, and it takes in a value called MC, or a value MC697. And then here we are creating a variable called count that will store 5. At least this structure is familiar. And of course, we can continue with this. You know how to initialize variables using the assignment operator. We don't need to go there. All it does is get whatever is to its right and put it in the variable to its left. This also demonstrates another data type called char, or character, that stores single characters. A single character can be 1, it can be a pound sign, it can be a letter. So it can be a symbol, a character, or a digit. But it has to just be 1. And the difference is the fact that it's in single quotes. Should you put it in double quotes? When you put it in double quotes, it changes from a character to a string, because strings are defined as anything that you enclose in double quotes. Yet, in fact, this is another error. You cannot say hello in Java especially, and C++. This is an error because this, if you saved it as a character, C, you cannot put it in single quotes. Single quotes are only meant to contain one thing. So char C can only have one character H. And if I want to store the next one, I can also go ahead and say char, maybe E can only have one character E. Okay. So this kind of notation, but of course you see this is tedious. I would rather create a string S and give it the word hello. Also, I cannot create this as a string and use single quotes there and there. That would also be another error. We've talked about the Boolean thing already. So Boolean is the data type, and whatever it saves is supposed to either be true or false. You can save it, create it by the way, and it contains no initial value. Then you just come on the next line and say B is true. You notice that this is not capital T, and even when you're assigning it to false, it is small f, like that, not capital F. Some languages use some languages are case insensitive, and that's whether small or capital, it wouldn't mind. Capital F false and capital true T, with a capital T, sorry, would not create any sort of errors in a language like Python and maybe even JavaScript, but Java behaves differently. And then you can create any other data types and use the assignment operator to get whatever is on the right to assign it to the variable in the left. We're saying here that it is very different from the comparative equals or the equality operator, because this is also called the equality operator. So this checks for equality. We shall see when and how, but I'm also sure that you've seen it before in the previous courses. While this is for assignment. So when we are reading it, we say H equals A, but the interpretation is get what is here, store it in what is there. All right. We're seeing here that if a variable is not initialized, most will default to null. Meaning, when you create a variable that is a character C and you terminate like this, if you do not assign it an initial value at the point of creation in memory, when the compiler creates this, it will store a default value null. Most of them, by the way, not all of them, most of them. But null, apparently, programmatically, null is represented using this. Just give me a second here. So a null character, programmatically, is represented using \0, like that. That is a null character. Thus, you might find that if you don't put any value, store any value, like if you don't say C is equal to K, in this space, there will be that \0 for null. But the moment you come and write K, that K will substitute whatever was in that location called C. So most of them, they will default to null. But if let's say you have int X, when it is created, the default value for integers is usually 0 until you go and assign a 10 to this, then the value will be updated to 10. Okay. These are like, sometimes you might find maybe I write some piece of code and take a screenshot and ask you for the output. Okay, so thus I can create a variable and not assign it an initial value like double G. The default value for double and even float is 0.0. So it would be like this. Meaning if I went and printed here system.out.print, maybe just print, not println, and I just put D here, and I did not initialize it, it would print 0.0 instead of 1.5 because this is not there. So knowing these default values will save you when the exam comes or the test comes. Okay, so under normal circumstances, try to initialize these variables. The issue with relying on these things that we refer to as default values is that you will most of the times end up having data in there that you have no control over. As in the variable X, or let's call this double, which is meant to store a double precision value. When you put 0, when you leave it empty, it will be 0.0. But then there are some compilers that you will put 0.000. Now, do you want it to be set to 4 decimal places? Maybe not. You let the compiler decide the default value to put there. So it will definitely assign it a default value that you have to deal with. So to avoid having unpredictable values, we always explicitly initialize our data. That's why here this is being assigned to true. We don't know, maybe the default one is false. So if you don't assign it true by default, it will automatically check false. So if you want to overwrite the default value, assign an initial value always. Even here, instead of it being the initial 0.0, assign it a 1.25. Moving on to the data types. Oops, let's do this. I want to clear. Okay. Moving on to the data types that we have, we've seen most of these already. You know them. The only difference is going to be maybe adding those that were not in other languages that we've seen so far. We use data types when we're declaring variables. We have two types of data types. Those that are inbuilt, what you would call primitive data types, and there are eight of them. And these, one of the distinctive features that they contain is the fact that they are not capitalized when we are declaring the variables. And you've seen them already. Take, for example, integer. The I or the int itself is not capitalized. Double, okay, or double, the D is not capitalized. Thus, this is categorized under primitive data types. Whereas the other one is the reference or class-based data types. Reference or class-based data types. And these, by default, are capitalized. So string was one of them, by the way, and any other class that you're going to create. So this actually tells us that the classes we create are like custom or user-defined data types. Okay, the classes we create are like user-defined data types, because when I create a class called person and I want to assign it a value, I'll say person p, right? You see that this is the same as saying int a number. The structure, syntax-wise, they're the same. So the data type comes first, and then the variable that I'm creating. It's just that now we will give them names. This thing that has the capital letter is a class. Whatever is created from a class is an object. So instead of calling this a variable, I'll now call it an object. Instead of calling this a data type, I'll call it a class. That's really the only difference. Okay. And here is a summary of those data types that we've talked about. The 8 primitive data types also have a sort of categorization, that we have those primitive data types that will store numeric values without decimal places. And those are integer. It has its range of values that it stores. This is in Java. In other languages, you will see they are different. Okay? So in Java, they are positive or negative. So they store negative or positive values, and they range between negative 2.1 trillion and 2.1 trillion. And then you have the 4 bytes. Okay, 4 bytes is the size that is reserved for an integer in a Java program. We are now avoiding those things of saying it is 4 bytes when it is on a 32-bit and then 16 bytes when it is on a 64-bit. I don't know if you have heard of those before, but if you haven't, that's okay. Let's just continue with the other data type. There is short. Okay, so short ranges between negative 320 and positive 32,000, sorry, and positive 32,000. So short is 2 bytes. Long, on the other hand, is negative 9 to the exponent of 18, or to the power of 10 power 18, sorry, which is going to store 8 bytes, sorry. And then that's negative to positive. Then the byte as a data type, it also stores whole numbers, and it will store between negative 127 and positive 127. It reserves, or it is the equivalent of 1 byte. Now, if you wanted to store this in their corresponding order, you would start with byte, short, int, long, in terms of like ascending order of the size that they store, okay? But also the same as with the range of values that they can contain. Meaning, when I'm designing a system that is storing integers, and I expect that storing numbers that don't contain decimal places, and I'm expecting that the highest value, even if it's a circle, the highest amount that anyone in this bank is going to have is 10 billion, okay? 10 billion. I will save that as an integer. I will save that as an integer. Why? Because I mean, it's still within the range. 10 billion are still within the range of 2.1 trillion. But should it go beyond 2.1? Maybe now I have 10 trillions instead of billion. I have 10 trillion. Maybe you're saving the money for a certain, multi-billion organization, and it goes beyond billions and it is now in trillions. You will save that as long. because to the exponent of 18, that's a very huge value. It's like the equivalent of 18 zeros, 9 and 18 zeros. Okay. All right. So that's how you would pick which one to use. But now, if I am sure I'm working with a system where the maximum value that I expect to receive is the students, let's say, not students, but we are dealing with maybe, okay, let's start with, if it's students max, really, in a Java system, and the highest I expect is 100, none of you ever gets above 100. Okay, some of you, you know what, but for now, none of you ever gets above 100, and you can never get above 100 anyway. So I would store that as a byte instead of int. So you notice that Java gives you the flexibility of the ranges of values that you can pick from. They are very huge at that. And then we have where is this? The floats, the numeric values that contain decimal places. There are two. There's double and float. Float allows this range between negative 3.1, positive 3.4 to the exponent of 38. We're seeing this reserves 4 bytes. You don't need to actually store this information in your head, by the way. These are things that you can always find over the internet. Maybe the important thing would be knowing how many bytes. Even the number of decimals that are going to be there, you don't need to really remember them. And then the one that is very big. So let's say you're going to store very huge values, but ones that contain decimal places, then you will consider going with double, because this is the range to the exponent of 308. But it reserves 8 bytes, and it can allow up to 15 decimal places. The other data types that don't fall in this category are Boolean, which stores true or false. Okay, you notice here that we don't even have how much space is reserved for them. You can go and find out why. And then the other one is char, okay, char, which stores any character in single quotes, but the space it reserves is 2 bytes. Okay. Now, in some other languages, you'll find that a character reserves just 1 byte. Yet here in Java, we are seeing that they are 2 bytes. You might want to read and find out why we say it is 2 bytes. And so here is a pictorial sort of representation for those data types that we have. So the previous ones, these ones are all primitive, and this table shows it here too, or this sort of hierarchy, that among primitive, you have those that are numerical, and among those that are numerical, you have the integral values, but integral values can be divided into those that are integers with whole numbers, which are bytes, short, int, and long. Whereas for the floating point values, values that contain decimal places can also be referred to as floating point values, which are float and double. In fact, this can also be read as floating point values, this one itself, and then this can be read as double precision values, but you don't have to worry about that for now. So character has only one, which is char, and then Boolean has only one, which is Boolean. And then the non-primitive, these ones are many, you cannot exhaust them, but we have things like string. This is built within, but it's not primitive. It was custom made. We can even say it was added because of the whole OOP thing. And then array, you see how it also starts with a capital A. So in Java, you can have an array that, like they created an array class. And thus you can even call the methods that belong to that array class instead of you writing new ones. Just like you saw in C and C++, you might not exactly have an array class that you can explicitly call or use. This is a table that shows the default values which are saved in your data types when you create them. So Boolean by default stores false. This is supposed to be in small letters, sorry. Character by default, see what it stores. The \u, but you can find out what the \u means, because I think I've told you at least that these are called special characters. Now, instead of it being 0 like this, \0 to mean null character. This is another way to write it, but find out what the U itself means, \u means. A byte stores 0, 0, 0. So you see that most of the integer-based types will store 0, except now long stores 0L. The L for long, to show that this is going to store large, very large values. On the other hand, floating point values will store 0.0.f, F for float, and then the ones that are double are 0.0.d. Now, this D is for the system to interpret, not you. So the system will use this to tell, oh, okay, yes, it is 0.0, but this is for a double, this is for a float, and so on and so forth. Let's see what time it is. Maybe we could have a break, short break. Do we really need one? Well, you tell me. Stop sharing already. No, first come back to sharing. Should we get like a 5 minutes break? The only problem with giving you people a break is you guys go off and don't come back. Well, not that I make any loss, but yeah. So if we kept marathon, hey, you know you're here to stay. So should we do a simple 5 minutes break? People to walk out, excuse me, walk out, stretch their legs, and then come back.
Yes.
Or you don't need it.
We need it.
What? How much did you pay for to get retake? Okay, so let's get a simple break, and then I'm not going to stop sharing. I'm going to leave this here. So after 5 minutes, I'll just resume. So at 3:22, I'll just continue from there. Oh, by the way, Timothy, you can pause if you want to pause, but if you don't mind having 5 minutes of silence in the video, leave it on. But hopefully you don't actually end up stopping the. Hopefully people are back. Okay, so let's continue and see how do we actually use these reference variables. Okay, so here most of the times, okay, and in fact at all times, when you create or when you're using someone else's class, you're going to get that class name and it becomes the data type. And of course, what this data type, what this variable is going to be doing is to point to an instance of that class. If you want to think about this in maybe a more direct analogy, so to say, remember when we talked about how when you have a class, no, a blueprint, and then that blueprint is used to create a building, that building is seen as an instance, is seen as an implementation of your blueprint. That's the same thing that this line means, that the object points to an instance of that class. And for that reason, that's why we call it a reference, because usually you point to things that you're referring to, right? When you point to something, you are referring to it. So the reason these data types are called reference data types or reference variables is because they point to an instance of a class. So the object points to a class, okay? And that's when you write string s is equal to hello world. What really happens is an object s is created and it points to the string that someone else created. So s is mine, but a string as the class was created by someone else to hold this kind of information. So s will be a reference to the string class that is holding the information hello world. The same applies to this. EMP1 is a reference that points to it just points to the employee class. And now we can store our information in the employee class. Of course, we've seen these variable constants before, or constant variables, if you want to call it that. But calling them constant variables has a nice ring to it, because constant means something does not change. And then variable means something can change. That's saying constant variable. It is like you're saying something that can change and something that cannot change, and you're putting them together. So to avoid that confusion, we rather call them variable constants, the kind of variables which we use to hold information that might not necessarily change. And how do we do this? Well, the keyword that we use is final. Okay. In other languages like C++, you've seen the const keyword. But here we're going to be using the word final. But final should be direct forward, as in my final word is, that's the last thing. Now, that can change. We all know it can change, but final here is something that cannot change. So the keyword that we use to create constants or variable constants is final. It just simply tells the compiler that the value held in this variable cannot change. Here is an example of its usage. Final double sales tax rate is equal to 4.5. Now, the keyword is final, but the data type, okay? The data type has to also be associated with the variable that you're creating, meaning, but I don't know. Let's see. Yeah, even in C, when you're doing it, even in C++, you have to tell us when you write const int or const float, pi is equal to, you give us the values for pi, right? So you have to associate it with the data type. Even here, final as the keyword just tells us the value this is holding should not change. But the value we are going to hold in there is of the double data type. This is the name that we are giving that. And we said one of the rules that govern the creation of constant variables or variable constants or variables that contain data that should not really change is that it's not even a rule, it's a best practice. It is that when the name that you give them should be capitalized. That's why you see sales tax rate is capitalized. Then the other rule, now this is a rule because it comes with errors. The rule is you should always initialize your constant, your variable constants. Always initialize your variable constants, because the rule would be violated if you go down here and say sales tax rate is equal to 12. Maybe it has changed. Maybe let's make it 12.5. It changed. When you do this, you will get an error. You can only change it from one place here. Because at the point of creation, once variable constant is created, it cannot be assigned a different value. So initialization is very important, very key in our variables like these, the variable constants. If you forget to initialize, you will run into an error when you come back to assign it an initial value. Now, this is something that I can easily take a screenshot of the code and ask you, so I write this and put that and do other things down there and then say the above code contains 5 errors. Identify them and rectify them. Or part A is identify the errors. And then usually there are lines. So you say line 1 has this error because line 2 has this error because blah, blah, blah. And then you go to part B and it says write the corrected code. So what would help you remember that this is invalid is because this is a constant value, and thus it should be, initialization should be at the very beginning. We move on to pi. This is how you would create it. Okay, there are others, just note the final keyword and also the usage of the data type that you want to hold plus the naming convention. The fact that the names are capitalized is very key here. Okay. How do we perform computations in Java? It's pretty much the same as other languages where we use operators. These operators have arithmetic operators like plus, minus, the asterisk for multiplication, and the forward slash for division. Do you now see the reason as to why M stroke H was considered an invalid variable name? Because the forward slash is a reserved operator in Java. It has a meaning. For that reason, you cannot use it there. Okay, so we go back here. These are used for those things that you already know. We know the precedence. Let's say if I have A plus B plus C divided by 3, this would be computed first because Bodimas Mudas what division comes first before addition. So if you want to be direct, or you want to only have A added to B added to C, then divided by 3 later, you need to specify or to use parentheses there to group these operations that are of a lower precedence to be performed first. But this also comes from your mathematics. The other operator is the remainder or modulus operator, also called the modulo operator, that returns to us the remainder from the division of 2 integers. Thus, when you have 5 modulus 2, the result here would actually be, the result here for those of us would be 1, right? Why? Because when you divide 5 by 2, you get 2, remainder 1. So the modulo operator or the modulus operator looks for this remainder here. The same would apply if I said 2% or 2 modulus 2, it would be 0 because when I divide 2 by 2, I get 1 remainder 0. The same applies to any other operation. So how we get the remainder is by using the modulus operator. On the contrary, the division operator works like you know it. So when you have 5 divided by 2, it would be 2.5. But then this, if you had set the results in an integer, so you do int, maybe x is equal to 5 divided by 2, it would end up storing 2 in the variable x. And the reason for that is that most of these languages concatenate. In integer division, the decimal values are truncated. Concatenate, probably because of that. So the decimal values are truncated. They are ignored or dropped, but that it should be something that is not new. Concatenation, we've talked about this operator. It's used to combine 2 strings. You can combine a string, okay, so a string George, like that, and you can also combine it with other variables, okay? So maybe this would give you George 2, okay? This would give you George 2, all that. You would test and see which one works, which one doesn't work, and maybe you would find out the reason as to why, or we will see it in the later demonstrations. It automatically is going to convert the numerical and Boolean values into strings before it is used in the println. What this means is, if you try to concatenate here, okay, a string and an integer, the integer is meant to be automatically converted into a string. Then they combine these two into one string like that. And of course, while we are performing calculations, there is a class here that is meant to be used strictly for performing these kinds of calculation, as in it contains certain methods that you can use when you're performing computations. Think of methods that you use to raise values to a certain power, which you call exponentiation, maybe rounding off, either rounding up or rounding down or rounding off, because all of those are there. Maybe you want to compute the square root, the cube root, the logarithm of a given number and stuff like that. These are some of the examples that you have. Second, okay. These are some of the examples that you have. You have the absolute, which returns the absolute value of x. Absolute really is, those of you that are from math, if I have absolute -1, it always returns a positive value, okay? So the reason for doing this, it could be that maybe you have a subtraction operation where you don't care whether the user has given you 4 as the value in A, and let's say 6 as the value in B. If the result here is -2, you will use the absolute function to make sure it always returns 2. So to you, 4 minus 6 is the same thing as 6 minus 4, depending on what logic that you are writing. And that's if you always want these operations to return true, then you will use the absolute function. It will return the absolute value of x. The same applies to the max. Max returns the greatest of 2 given values. So if I give it 1 and 2, it will return 2. Min, it will return the smallest of 2 values. So if I gave it 4 and 6, it will return 4. Pow, or power, xy returns, it's going to raise x to the value or to the power of y, meaning pow to 4 is the same as 2 to the power of 4, which would be, from your mathematics, I also don't know. And then random is going to generate a random number between 0 and 1. Now, this random number between 0 and 1 might be 0.2, 0.6, 0.9, but it might also be, depending on the scale, 0.555, because this is still between 0 and 1. If you want to round, just doing round will just return the closest integer to x. This might not be rounding off or rounding down or rounding up, but you can find out if those kinds of functions exist. This just returns the closest integer value to x. Let's say if it received 2.5, it would return to you 3, okay? Then if it receives 2.4, it would return 2. So we know one of these is like rounding up and the other one is rounding down, or call it rounding off if you will. And then the one that can be used to perform the square root of a given value is the SQRT, and then give it that value. So the square root of x is what it will compute. Of course, we have special operations while you're trying to perform, operators while you're trying to perform these computations in Java. So the special operators most of the times are used for writing shortcut code. What is shortcut code? Imagine things like \n instead of using the println function. So this would be considered a shortcut instead of that, or it's a shortcut to the println. But of course, there are others that we use that are not exactly the ones that you have in like print statements. One of them is the increment operator, and we have seen, or we should know by now, that it adds 1 to a variable, okay? And then the decrement operator removes or subtracts 1 from the variable. Now, how do we... Okay, so usually when you write C plus, it is going to get the value in C and add 1 to it. If you write C minus, it's going to get the value in C and subtract or remove 1 from it. Well, what I want you to practice or do is look at pre stroke post increment, okay, as well as pre-stroke post decrement. That somehow, I know that the computer science people were taught this because I'm the one who taught it, but I don't know about the other people. But I expect all of you to go and try to understand this more. Plus C and C plus have a slightly different inclination to them or explanation. One of them is a pre-increment, the other one is the post-increment. The same applies to minus C and C minus minus. So this is a pre-decrement, whereas this is a post-decrement. Both of them are removing 1 from C. That is for the case of this, and here they are adding 1. Hey, these are removing 1, these are adding 1, but the usages, depending on where you use them, the result might be different, or they might have a different impact or effect. So please try to read more about this and see for yourselves. I might have it somewhere in the notes so that I'll keep talking about it, but I might also forget and just assume that you already know about it because it should have been taught. Well, how do we use assignment operators with these arithmetic operators? You have an operation like this down here where you say total is equal to total plus 5. We're still looking at special operators. That this is fine, but someone else can rewrite it. Okay, someone else can rewrite it. Oh, by the way, no, I won't ask you. Instead, because this was meant to be like an in-class kind of discussion. But when you have total is equal to total plus 5, someone else can rewrite it as total plus equals 5. This is the shortcut version. Okay, so total plus equals 5 is the same as saying get the current value in total, add 5 to it, and store that in total. Because this is, if total currently contains 1, you shall get that 1, add it to 5, and then you produce 6. The 6 will be saved here. This is another way or a shorter way of writing it. Now, usually we do the same with increment operators, and this is what it would look like. But just give me a second to hide this. So when you have, let's say, what would work? Yeah, we can use this. So let's say I have a variable, x, that is storing the value 1. I can come and write x is equal to x plus 1. X plus 1, that is fine. But alternatively, I can write x as x plus equals 1, and that would also be okay. The other one, if it is just adding 1, 1, would actually be x plus plus, or better still, plus plus x, like that. Okay, any of these really works, all x plus plus. But you go and find out when would they produce a different output. But both of them will add 1, 1 value to them. On the other hand, if I have, let's say, yes, please.
That special operator only works with increment and decrement.
Which one?
Those are the ones of what? Of the shortcuts.
Mm-hmm. So from what, wait, let me type this. From what you're saying, does that mean that it wouldn't work in this case here? Or it wouldn't work here?
Oh, yes, that's what that was I was asking.
Are you sure about that? I understand what you meant by it only works with increments, because it actually is incrementing. Because here, when I say, let me just focus on 1. In fact, let me use the post and say x plus plus. The interpretation behind this is get the value in x, add 1 to it, right? That's the same as saying here, get the value in x, add 1 to it. X plus equals is a shortcut for that. But also, this is the same thing, because this means add 1 to x. Isn't that incrementing? I don't know. What's confused you, or what do you want to point towards?
I've understood that, like, you can use the same if you want, let me say, to divide or to multiply. You can use the same. You can say x divide equals 2. Is that also like applicable?
Oh, so I think I get where that came from. this, what I was demonstrating here was only for incrementing, okay? Was only for incrementing that if you're trying to add one value to X, you can use this or this or this, but it won't be the same, okay? This down here won't be usable if we now want to divide whatever is in X by 1 and then rewrite it like this. No, it won't be the same. What I demonstrated was it's a different way when you're using addition and you're trying to just add 1. In fact, the same wouldn't be if I did this. If I came here and added 2 to this, oops, add 2 to that, this would be the same thing. You add 2, but then this would cease to work. Okay, so I was just looking at the alternatives of using the shortcuts and how you can substitute it. But yeah, I get your concern. Thank you for the correction. So the same would apply if we wanted to subtract. If I want to subtract -2, I can just come here and write this as -2. Alternatively, if it was just subtracting 1 value, as in -1 and -1 here, then I can add the x minus, and it would work pretty much the same way. Okay, so that is out of the way, clear, remove that. Here we go. So that is really what I was talking about with the shortcuts. Well, let's move on with the program that demonstrates the usage of variables. I'll just explain a few things here and there, and we move on. So here is a class called example2. Okay, so class called example2. Now you're noticing a slight difference that when you do not put the keyword class here, okay, when you do not put a keyword class here, most of the times it is considered to be the default access modifier. Maybe the question we should ask here is, what is the default, okay, access modifier in Java for classes? Because, excuse me, most of the classes will refer or will have a default one, really. And depending on what you're trying to create. In other cases, it might not always be the case, but most of the times this will be private. Okay. By default, most of the times when you don't put a keyword, there is a default. We call it the default level, but for now, let's give me a second. Yeah, if you don't put anything there, it is going to be hidden by default. Thus, if you want to make it private, public, you have to add the word public there explicitly. So when it is not added, by default, it is private, but we shall see when would you want to create a private class or a public class. Then for the main method, we said, regardless of whether the class is public or private, you have to make the method itself public. So public static void main returns nothing. It is shared by all the instances that are going to be created here. So it contains common things, and then public for public access, blah, 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 blah. Then inside here, you can create a variable. So int var1, we are declaring an integer variable. Another integer variable, we are initializing it with a value, and then we come and print out the information on the screen. So this is how we use the concatenation. What is here is a variable, and we're saying var1 contains, there's a space there, plus var1. So this will print var1 contains space 1024. Okay, why? Because it will get, when it reaches here, it looks for in memory, is there anything named 1000, I mean var1. When it finds it, then it picks the value and substitutes it and puts it there. So on the screen, you see var1 contains 1024. Then when you come to var2 equaling to var1 divided by 2, you're now performing a calculation or a computation. You're saying get whatever is in var1, divide it by 2, store it in var2. And then you come and say var1 contains var1, I mean var2 contains var1 divided by 2, and then you come and output it on the next line. So you see the way we are using print here. This is println and then println. So sometimes what we do when we are trying to assess whether you understood the usage of these things, which I still once again can take a screenshot of this and ask you what will be the output displayed on the screen. So knowing or noticing that this print will remain on the same line means that on the screen I'll see var2, okay, contains var1 divided by 2. What is 1024 divided by 2? Well, you tell me. 5. Okay, which one is that? 1, 2, 512. So it will be displayed on the same screen. But the reason as to why that is the case, because we didn't use println here. If we use println, then the 512 would be put on the next line. Of course, the first one, this var1 contains, is what will be printed up here. So var1 contains 1024. So the thing that will move the cursor is this ln. It will move the next output to be put on the next line. So that's why var2 contains is seen on that line. But the reason we are seeing 512 being displayed here is because print is what was used instead of println, because println said it prints the contents and moves to the next line, whereas print prints the content and remains on that line. So the next output would be put right after, which would be here. Does that make sense? Is there any question before I want to close this and go to the next slide? Is there any question? Any question? None? Well, this is another one that demonstrates, gives you more, more work to do with variables and all of that. At least it goes beyond just using integers and uses the long variables, just in case you want to see how that happens or how we use those. So you have a class called light, okay? And this class has a main method. So this main method, and inside the main method, we have a variable called light speed, and it is storing an integer. I have another one called days, and it is long. And then you have another one, second, is storing long. Distance also is long. So you see the usage really is still the same. So we're storing maybe the light speed, which is the approximate speed of light in miles per second, is that 186,000. Wow. So the amount of money that some of you would have, and now you, if it is in millions, every one of us here would never come back to class, I assure you. Anyways, 180,000. And when you try to save days, so days is 1,000. But the difference between this and that is that the maximum value that we can store in this variable days is higher than the maximum value that we can store in the light speed variable, because this is long and that one is int. But that shouldn't be really a worry. Though most of the times we choose, and as I earlier stated, if you are aware of in advance the maximum value that you're going to store, then you choose correspondingly what sort of values that you're going to have. Now you see, you couldn't have used short for light speed. Why? Because we saw that short stores a maximum of 32,000, yet 186,000 is above what a short, what the short data type can contain. That's for that reason we stored it as int, because we know in advance the kind of values we're going to store. Now, the reason maybe for storing long days as long could be that you expect this to keep growing over time. The value that they will contain will go above 2.1 trillion, which is what we said is the highest value that int can store. So, and there you go. We now try to convert the days into seconds. Yes, please.
If at all you had like the 32,000, it is short, but can you also decide to store it in long?
Yes, you can. You can decide to store it in long, but that would be like a wastage of space, if I could put it that way. I know that the maximum value that I can store in this program will never go above 32,000. Think about max. That no student ever gets a mark that is above 2.1 trillion. So why should you store it as long? No student even ever gets a mark that is in the range of trillions. So the maximum a student can get is 100 for anything related to marks. Thus, I can gladly come and create byte marks. This is byte marks, because I know the maximum value they can contain is 127. This will never exceed 127. But nothing stops you from creating it as an integer. Okay, but this is like wasted space, because if byte as a data type reserves only 1 byte in memory, yet int as a data type reserves 4 bytes, it means you have extra 3 bytes that you have stored that you don't need, that are wasted, right? Especially because of the usage of that program. Thus, to optimize, to have a better performing system, go ahead and use the right data type, the appropriate data types, ones that you're sure are going to be used appropriately. Okay, and so seconds, we convert these days to seconds. We know how to do the calculation. And then we do distance being the light speed times seconds. Well, worry not about what the program means, as in what are you trying to compute. The important thing to note here is the usage of the data types, okay? And they are used pretty much the same way as in other languages. So we will go ahead, just a second, go ahead and print out the message, but also pay attention to the printing. We're using print here, meaning the output will be on the same line. So in, we put the days, whatever calculation will have come here. So 1,000. So in 1,000 days, light will travel about that much distance. Okay. So this was just meant to demonstrate how you can further use these data types in your program, and also, play along with the output on the screen, because this, if you give it to someone who doesn't know what they're doing, they will think this goes on a different line, even this on a different line, even this on a different line. Yet in reality, or in actual sense, all of this information is going to be displayed on the same line because of print. The print ln, you won't even see its effect if there is no other print option at the bottom. You will only see its effect if, let's say, I had system.out.print, maybe full stop. That full stop would be taken to a next line because of the ln. So while you're practicing, also learn to pay attention to those, or see the output and manipulate them. Be curious, really, and manipulate them and see how is it different? Why is this going to the new line when I don't want it to go there? Or how can I even print all of these using one print statement, but print them on separate lines? Blah, blah, blah. Okay, that actually should... Oh, the differences between Java and C are these ones. Like, sorry. These are things we've talked about already, but let's rush through them. We are about to finish. We are almost at the end. Yeah, just a few slides, 3 or 4 of them. In terms of how memory is managed, you must have talked about memory management. Maybe we did with, I don't know. But how memory is managed is that you will not see those things called pointers that we talked about with those people of C. I don't know if the C++ people went as far as pointers, but you will not see those things called pointers here in Java, because Java automatically has its memory managed, okay, through something called the garbage collector or the garbage collection. So in Java, memory is automatically managed with garbage collection, whereas in C, you manually have to manage your memory. You don't have to worry about that. At least you know it has to be managed manually in C and C++, but it is handled automatically by something in Java. For about in relation with this means is that when you write a program and it is written on a Windows machine, we can also install a JVM on a Linux machine and the program runs the same way as it did in Windows. Whereas for C, the programs you write are platform dependent. If any of you is going to remain in programming, you will later on find out that the way we write a C program for Windows is different from how we write a C program for Linux, different for how we write a C program for Mac. Because the language itself is platform dependent, whereas with Java, there is platform independence. And of course, Java is object-oriented, whereas C is procedural. Okay, you cannot write procedural code in Java because the language itself is purely OO. And then Java has quite a number of standard libraries as compared to C. C has a minimal sort of a minimized sort of standard library. It has standard library, of course, but Java has one that is richer. That there are things in C that you have to build from scratch, but they are there in, let's say, Java, and someone has already built them. You just reuse them. That's what we mean by a richer standard library. But think of, if you're trying to relate what a standard library would mean in C, think of those header files. Those header files are considered as libraries. stdio.h, iostream, Honio, I hear iomanip, blah, 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 all those things. They are considered the standard library. Java has one that is richer, really. The syntax, Java uses classes and OOP extensively. I mean, classes and objects extensively. Everything that you do is a class. You have to, whether you know what a class is or not, in Java, you are going to have to write classes right from the onset. Whereas in C, you write more functions. I mean, your very first program in C or C++, it had a main function. Even when you didn't know what the main function, or what a function means, you are already writing the main function. And then in here, you see out or you print F. So C is more function oriented. And of course, let's also look at how we read input from the keyboard. Today's class, yeah, we are going to end in the next 15 minutes. So I was checking here. Let's end so that you have practice questions that will also be posted on the platform, which will become an assignment, of course, definitely. And I told you last time, I'm making them assignments so that you guys do them. If I only leave them as practice questions, you guys will not sit down and practice. So there will be many assignments, almost every after 2 weeks or one, but it is meant to help you anyway. So let's show how we read inputs from the keyboard. We remember that in C++, you use like cin to put, maybe to store something, let's say in OP, if OP is a variable, or in C, you'd write scan F, and then you pick this as, let's say, an integer and store it in the address of maybe some variable. Let's also call it OP here. These do the same thing. These are for inputs. Well, in here, in Java, the way we pick inputs is varied. Like there are different ways, really, but we're going to learn one today, and maybe later on we shall see the other ways that you can pick inputs from the keyboard. So the very basic one uses the scanner class, okay? And I'm calling it scanner class because of that. And it is found inside the java.util package. So soon we will learn what a package is, but really, if you have to think about it in layman terms, a package is a sort of grouping, right? A collection of things. So the java.util package contains utility functions. That's what the util is. Utility functions that we can use in Java. right? Very simple stuff. But these functions are put inside classes. So there is the scanner class, whose main work is meant to be, wait, all right, whose main work is meant to be picking data from the keyboard. And that scanner is going to be the class that we use for input, but also we need to tell the compiler where it is found. So it is found in this package, and this is the name that we want to use. And of course, the scanner class, there, is used to pick multiple pieces of data. We can pick integers, we can pick double, we can pick string, and all of these are going to be gotten from the user, assumingly. It can read inputs from various sources, but for now, we're going to focus on reading these inputs from the keyboard, okay, which is apparently the console, that black interface where we usually see the code running is referred to as the console. So this is a program that demonstrates how you can actually pick inputs from the user. I guess there's one more example ahead, but I'll explain this and see if we should explain the second one as well. So to use the scanner class, we need to import it. Now you're seeing for the first time how you actually import and use. We've used other people's code already, but we had not explicitly, directly imported them into our program. So if you know in advance that the program I'm writing is going to use, to require to read inputs from the keyboard, then you will call the scanner class. So this line here is like the equivalent of that statement we usually say, the hash include, what we call the preprocessor directive. So in fact, now the equivalent of the preprocessor directive, this thing include is the preprocessor directive, like this. Excuse me. So your import is the equivalent of the preprocessor directive. Now in these in these angle brackets is where you would put things like IO stream or std IO.h, or maybe for those of us that were writing in C++, it would be IO stream. And thus, what this line was telling our compilers back then was, look for a file called stdio.h and load it in this program. Or here, look for a file called iostream and load it in this program. I'm going to need some functions that are here and some functions maybe that are there. The same, when you want to use the scanner class, you tell the compiler to look for it and where it is found. So that is what that line does. And then now we already know public class. This file will be called input.example.java. Then we have the main function. And this is how we create an object that we use to pick data, or to pick information from the user. We are using the very same scanner class here. I have another lecture to attend, what, create, request. Now you see, I tell you, go home. Okay, please go and have fun. Oh, wait, did you say you request the recording? Okay, you request the recording from Timothy. He's the one with coding. So this is how we create the object that we use to pick information. So we call the scanner class. You see the capital S there. And then this is the object. You see the small s, the difference. Earlier, you remember when I asked you string like this and string like that, and I said one of them would be invalid. So the second one, which is considered the object, if you want to create the same name, let it be in small letters, because we say the language is case sensitive. That's string with capital S and string with small s, totally different things. So now people should not say, but you said scanner it comes within, it is inbuilt, but then you're using it as a variable. This is small s, that is capital S. So this is the class, that is the object name. And then we create that object by calling the same scanner class, and we instantiate it using the system.in. Remember earlier when I said system.out and I called it the output stream. Now this is the input stream. So this line, cram it if you want. This is how you will always create an object for the scanner class if you want to pick information from the keyboard using scanner. There are other ways, but with this, This is constant. This here is constant. Even this is constant. The only thing that will change is the name. I can call it and create it and call it SC. I can create it and call it input. I can create it and call it George. But these other things, they're supposed to be there. New, let's not talk about it for now. We know scanner is a class. We know that is the input stream. That is all you need to know. So now the next thing, so that line creates an object for the scanner class. The next line is just displaying information to the screen, saying enter your name. We're prompting the user to enter their name. You notice that there is no ln here, so this will be displayed on the same line. What that means is that that blinking line will be displayed here at this very spot. So if you want to take the blinking line to the next line, then you'd put ln there, then it will be put somewhere here when we are running the code. Then now to actually use the object to pick information, this is how we do it. We call the object scanner and then call a method to pick the information. The next line method, it's a method because of this, but you can call it a function. Next line function, next line method, that's all okay. So the next line method of function picks a string of information. Whatever you enter is going to be considered as a string, and then we shall save it in a variable called name, which is of the string data type. Remember, our expressions are evaluated starting from the right, going to the left. Thus, what this will do, on the keyboard, on the computer, you see the blinking line. And once you enter whatever you've entered and press enter, then they will pick whatever is at the console and save it in the name variable. And that is how we will be able to output it on the screen. So next line, which belongs to the scanner class here, because now we said, whenever you see scanner, it's a reference to the scanner class. So the scanner as an object, which is an instance of the class, it keeps referring to the class because it is in that class where the method next line is defined. So the next line method contains the instructions that the compiler will follow when it is picking a line of information. This can be George, I press enter, or it can be George William, I press enter, or it can be 12, and I press enter. Whatever I've entered will be picked as a string because we want to save it as a string this side. Then when we output it here, it will also be output as a string. In case this doesn't make sense, worry not. The next class when we meet, I will also do a recap of these last slides because I think, let's see, yeah, these two are the last slides that demonstrate how you read different inputs. But in the next class, I'll also start here by running this code and you see it in action. I'm not going to run code now, but I'll run it in the next class so that you get a feel. Running it now, there will be questions you want to ask, and I'm sure you're exhausted. There's no point in teaching you programming for more than 2.5 hours, really. So here, this is a program that demonstrates how we read different types of data. Now you're seeing a different way of importing the Java class, the util class, sorry. So you will see this a lot in most programs. Instead of writing java.util.scanner, there are other classes that are involved in this package, okay? I say the package, but think of a package as a folder. So a package is a folder, really. And inside that folder, that is where there are so many classes. And remember, each class is a file. Meaning, in a folder called Java, there's another folder called util. And inside that folder called util, there is a file called scanner.java. So if you are curious and you want to go and see which other files are there, feel free to look for a folder called Java somewhere on your C. It is there. And then inside that folder, there's a util folder. Inside that folder, you see a file called scanner.java. Now, the curious people usually are the ones that learn most things that are not really explicitly taught. So if you want to be that person, please go and check. You see so many files. So what this does is to tell the compiler to load everything, okay? To load everything. So the star, which is also referred to as a wildcard, a wildcard, it simply tells the compiler to load everything that is in that folder, that package called java.util, and it will, of course, also load scanner. Maybe this program has to use other functions that belong to the util package, but it would work the same way if you just said java.util.scanner. We already know what that is. We already know what that is. This is just outputting information on the screen. There's no need to explain that. We already talked about this. Scanner is the name of the class. In is now the object that we are creating. New scanner system.in. Okay, so we said this is almost always constant. When it's going to change, I'll also tell you when we change it and why. So this is me displaying on the info on the screen to enter your name. Same line, so meaning the cursor will be here when the user is entering their name. Now, the other way that we pick now, no, not numbers. The other way that we pick a line of data, more like a string of data, is by using the next keyword. Okay, the next function or next keyword. Now, these things have like different usages. Okay, so next can be used to pick a sentence, a whole sentence. And so the same applies to next line. But there is a slight difference. One of them, I'm not going to tell you which one, but I want you to read about it. One of them, if you're entering your data, let me just do this, where is there. So one of them, between next line and next, when I enter George, William, like this, one of them will only pick George, whereas the other one will pick George William. So you will test when I'll post this today. So when you're testing, go ahead and see which one picks only George, which one picks only George William. And until you're practicing and you find that both of them pick George, then you will know what to tell me when I ask you if we meet next week. So this is another way that we can pick a string of information. So I'm picking the user's name and storing it in name. And then I output, tell them to enter their age. Now, how we pick integers is by calling the next int. Okay. So you see, instead of next line, instead of next, we're saying next int. So next int method is the one that calls or picks integers. And then we output. There is no point in explaining that. Then how we pick a single character. Single character. A little bit tricky, but easy, really, if you give it time. So we're saying create a variable called ch. It is of the char data type. You're going to pick a line, but from that line, pick the first character, the character that is at index 0. Do you guys remember arrays, how they work? So imagine, even your name, when it is being picked, it is going to be picked as an array. So if you enter the name Charlie, who wants to call himself Charlie, like that, when you call the next method, it will pick all of this. All of these will be picked. But when you say in.next.char@, pick the first character, because this will be 0, 1, 2, 3, 4, 5, and 6. So when you say char@0, it will pick whatever is at the first location or whatever is at the first index. So whether you have entered very many characters, it will ignore them. We said enter Y or N. Y or N. Now, there is no direct way. So we cannot say next car. Just like we've seen next int, there is no method called next car here. So you won't see it. But at least there is a way to pick only that one by specifying the index where we want is to be picked. Meaning, now this is for the curious ones. Meaning, if I have a long name, I can decide to pick only the second character by changing that index. If that doesn't make sense, never mind. But if it makes sense, well, we are almost at the same level of observing. So then the other thing is output, enter your salary. You notice that all of these things are being displayed on the same line. The beauty is, whenever you pick an integer, so after this, you're going to press the return key or the enter key, so the cursor will go to the next line. Even here, it will go to the next line. Even here, it will go to the next line, because you might ask, but then after I pick data, why is this information being displayed on the next line? It's because after you pick this, you press the return key, and that's the next output will be put on the next line, even if it was print, not println. And so how you pick a double, you call next double. So you see, next int, next at character 1, character 0, sorry, char at, and then next double. Meaning you can already guess how others can be picked. If let's say I want to pick a Boolean, maybe you can guess that it is next Boolean or next bool, but you'll find there's a way, there are places where we can find these definitions. Now we start outputting this information. This is the last slide. So there, this is just outputting. That's why I'm not even explaining. The only thing I want to explain is here. Whenever you are done with reading information using the scanner function, you need to close it. We shall talk more about this, why you need to close it. I'll talk about it in the next class. Now, we are done. What you are going to do is go and do these things. So question 1 is out of the, you're not going to use it, okay? You're not going to use it. I mean, you're not going to attempt it. I even feel like question 2 should not be attempted. Attempt question 1 and 2 only for practice. The rest are the ones that are going to be the actual assignment. So which data type would you use to represent the following values? This is really practice. A child's age, someone's age. If I make it, if I allow you to use, to add question 1 and 2, I would be very strict. For example, child's age. Yes, it is an integer, but which child do you know would have 2.1 trillion years? So that's why I'm saying if I make it part of it, so of course now that I'm giving solutions, hints, there's no point in making it. So I would expect here the corresponding one would rather be a byte. Why? Because it is the smallest that we can store for age. I cannot create a variable age and make it a float, because whose age do you know? Except you people that claim I was this year. I have not made yet. No, I've not yet made 25. I was born in December. What do you mean you were born in December? You were born in 1900. So the moment we get into another year, you are old. Anyways, back to the point. Employee salary. Employee salary. You people that have worked, sorry to those of you that don't understand Luganda, but yes, feel it. Whether somebody has children or not, now you people should know better. At the end, some of you, okay. Whether someone has children or not, it is a question. It is a true or false kind of question. Apartment later. Apartment. Now this one is not fair because some of us have never stayed in apartment. Now imagine we are asking you to store apartment letters. But anyways, an apartment letter, you've seen some of those rooms might be like 5A, maybe 20B, maybe room 205. You notice that this is not exactly a number, but rather a combination of characters, a string of characters. So this would be byte. Though if you save it as age, maybe, salary would potentially be, because I don't expect most people to earn above a certain range, I can just make this float. Okay. And then this is going to be Boolean. This will be string. So create a program that goes to liters, program will work, declare into, okay, one will hold and the other will hold, and then after conversion into the gallon, well, now that's C convert it, for example, and also it do okay. Yeah, add that. You can start from question 2 going forward, because what this means is that's assuming you will do this yourselves, because even question 2 is very easy. All you would need is to find out how do I convert from gallons to liters? Know the formula and then convert accordingly. Add the formula in your program. Don't go to ChatGPT for these simple things, you people. And here you have question 3. So what I want to do, let's see, this is 4, 5, 6, 7, 8, 9. There are 9 questions. Now for this assignment, you will attempt 4 questions. Last time you did only 3. So the assignments will keep going. They will keep increasing. We shall get to a point where all the numbers that are there are compulsory. Maybe the semester will be done by then. But imagine if we do one assignment every week, you guys will also have gotten time to practice these things. So pick any 4 actually. How many are they? 2, 3, 4. I'm going to make it 5. 5 would be better. Yeah, but 5 now. 5 would mean you will copy a lot. Even though it's safe for you, still copy. Anyways, 4. 4 numbers. I'll post the assignment today. 4 numbers are what you're going to pick from these practice questions, and then you submit next week. Today is Thursday, Friday, Monday, Saturday. Okay, you submit it next week. The assignment should be due before the class, so that in case we talk about the things that are in the assignment, no loss made. So you submit it next week on Thursday at 11:59. The deadline will be 11:59. Is there any question before we proceed? Oh, sorry, before we end, there's nothing to proceed from really. Any question? Compliments? Complaints? Okay, then I should ask you, today's speed. Can you guys, like, is this something you guys would be comfortable with moving that fast? Because we went through an entire lecture of 37 slides. Does this work? Does this kind of speed work for people? Or you guys are used to the other one, where there are a few banters left, right, and center? And then we cover only 8 slides, but still a lot of content said. So the silence is going to be taken as that speed is fine. So even when I come physically, we shall move that fast through the material because you guys, you've been there for a month now. So you have roughly 2 months remaining, approximately 2 months remaining. The speed is not fine for me. Calvin, don't worry. What you do in these kind of cases is ask, right? All mention it. Like, let's say when we're in class and you feel like I've rushed through things. Yes, I've explained, but rushed through and you did not understand anything. You can always say, sir, I've not understood this. Could you please shed more light? And then, feel free to always stop me. But for now, since you're the only one out of all the people, I will try to reduce physically. By the way, I don't move this fast. Online, yeah, usually it's a marathon. So now I know what to do. Whenever we lose time in the physical classes, I will come online and get revenge. Eureka moment. Okay. Wagwan modern. Where one tell the man?
Yes, sir. But sir, I was requesting, if possible, you could share us with the slides so that as you are going slow, we also read slow. We get more hint about the points. Because now we are speeded then again. Yeah, obviously you also understand we picked few content than what you would have picked if we were having the content. We have read before, now we have the questions to ask.
Okay, I don't mind. That works for me. It only has one challenge where when you give material out, people start feeling like, I already have this. What more is he going to tell me? I already know what is on that slide. They will now be on their phones, right? They will now not pay attention in class. That is the reason as to why I put, if you check on the platform, there is a book that contains most of these principles that we are studying. I want to think I even put the course outline. I don't know if I did, but I should put the course outline. That way, I don't give you the slides until we are done covering them, but there is a book that contains most of these things. So if I say today that the next time when we meet, we are going to talk about maybe something called programming structures. Now, in the book, there is a whole chapter talking about programming structures. You go, you read about these programming structures and see, okay, this is what, okay, I see. Now, when you come to class, the slides will summarize what you found. But then if I already give you the summary, I'm limiting you in that summary. Modern, does this make sense? Or you really feel like you should have the slides?
Yeah, it makes sense.
There's a bat coming somewhere.
Yes. So I think in our group, if possible, you could forward us like the topic hints. Okay, Then we also make our personal slides so that we revise before you come about that very specific chapter we're going to talk about. Would it be possible?
Yeah, very possible. So, but anyways, let me put the ball in your hands. I'm going to upload the material even for the next class. Usually I make changes to them. Actually, it's the other reason I don't usually share them. It's because I make changes to them also. Like maybe I'll be here and I'm like, oh, by the way, this concept would be nice to add in these slides because I know it wasn't there last year, but maybe along the way, all as I'm talking to people, all as I'm interacting with students themselves, I pick a certain idea. I'm like, let me add this there because these things change. So for the cases when I make modifications to the material, I will always tell you. But for now, let's say what we shall cover next week. I'm going to put the slides there, plus the ones for today. If I make changes before the lecture or even during the lecture and when I'm presenting, I'll say, okay, so I made some changes. I will update those so that in your revision, the next revision, now you have the new slides, but you'll be having the slides that have to be covered in the next class before. What I want you to do is not to misuse them because, I mean, you can have them and not even understand them, but I don't want you to feel like when I read these things, I will understand them. So I'm not going to even pay attention in class. I'm not going to pay attention in the class. Okay, that's the reason. These materials in advance, but it will be up to you guys to behave, if you can call it that. To be up to you to behave and appropriately use the materials in the right way. So yes, I will upload them. There was a suggestion in the chat where someone is saying they request for the case of due dates that are being given to you to be 2 weeks since they are new concepts. Edward, it's a good suggestion, but unfortunately, I'm not going to honor it. The reason as to why I'm not going to honor this suggestion for now is because we haven't gotten to the concepts that require you to have 2 weeks. See, 2 weeks to a student, even the one when I'm saying you have 1 week, some of you will start this assignment next week on Tuesday when it is due on Thursday. You don't need 2 weeks for this really yet. When you need 2 weeks, I'll be sure to give you 2 weeks. I can assure you that. For now, all you need is 1 week because that work at your level, if you sit down on Saturday and Sunday, you'll be done. In fact, even Saturday alone, you'll be done. So there is no point in giving you more time to be lazy because you will actually be lazy. You'll be like, 2 weeks. I will sit down the other Saturday and do this work when I'm free. You feel like you're busy, or you feel like you have a lot of time, and it will be more pressure on you. So no, for now, I'll give you 1 week for this assignment and probably even the next one because it is also still fairly simple. But the fourth assignment, if it is to be there, you will probably get 2 weeks because that will be requiring you more time. I might even put you in groups where you need actually more time to meet with the group members. So yeah, the suggestion is taken into consideration, but not for this assignment or even the upcoming one, but the ones where you actually need 2 weeks. Thank you though for pointing it out. Is there any other question, suggestion, compliment, comment, or nothing? So we close the class here. Okay, I guess this is more like it. Well, this is just strictly for the class coordinators who are still here. On those forms, if you're writing now the end time, if we started at 1:40 to 3, because what do you mean 4:36? Just write 4:40. That gives at least like solid 2 hours, not 2 hours and 4 minutes or 1 hour and 5 minutes. I hope that makes sense. Modern, do you want to say something?
Yes, sir.
Yes, please.
Sir, I was requesting, if possible, like the way we went through these slides, would it be possible if next lecture would meet physically, then you take us through the practical work of these very concepts that we are studying?
In the next lecture will most definitely be physical. In fact, I even intended to come today, but something happened that made me abruptly change in the morning at 6. That's why I did not show up, but I wanted to be there physically. I prefer teaching programming physically. Ask the computer science people. There were a few classes that we had online, by the way. My case, I prefer it that way because I know I've had complaints from students how they don't find it easy to understand these things online. And also, we know the sort of distractions that you guys get. You put yourselves in positions where you're very distracted, and then you claim not to understand physically for that class. But just in case anything comes up, still for the class that will be online, it will start with the practical things, like looking at the practical, like writing. How do you pick information from the keyboard? Do it when you're there and we all see, then maybe even give you time to practice if we have it. I think that Friday we need to come up with something. We shall agree when all of you are there. Now, not all of you are in the class. We will agree on Friday. We have a certain time that we're supposed to meet. I want us to start using it for the practicals, even if I am not there physically. But that, we shall talk about it in the next class. Class coordinators, if you're still here, please, if I forget or anyone, if I forget, kindly remind me, okay? Is there any question before we officially close? It's almost 4:40. Okay, so please, someone should ask a question so that we get here at exactly 4:40. I'll get out of 4:40 so you don't feel like your time has been cheated. But knowing you, my good students, you don't usually have questions. Eh? I mean, you understand these things right away. How could you ask? Nothing. All right. Have yourselves a great evening, nice weekend. Please do not drink and drive. Goodbye.